If you're thinking about including encryption in a software project, the first thing you need to know is there are more ways to get encryption wrong than to get it right. In this video, I'm going to walk through some of the common ways people get encryption wrong, even for simple tasks. The first thing that's worth bringing up is the one that might save you the most amount of work. Under no circumstances should you ever try to create your own encryption scheme. That work has been done for you, and far better, by other people who have literally spent lifetimes researching and testing encryption algorithms. Encryption is extremely difficult to get right, and even the experts poke holes in each other's work all the time. In fact, that's the idea. For a concrete example, let's look at a simple Python program that uses existing encryption libraries and get some idea of how things can be used both wrongly and correctly. In the Python ecosystem, we have a handy third-party library called Cryptography, which I've installed in my system for the sake of this demo. It gives you both high-level recipes and low-level primitives. The vast majority of the time, you want to opt for the recipes, the high-level pre-packaged ways to accomplish common tasks. That saves you the hassle of re-implementing the bits needed for those tasks, and also spares you from some common pitfalls. But you still need to be attentive. In this example, I'm using the fernet function from the cryptography library, which lets us take a given piece of information, encrypt it with a secret key, and then decrypt it with the same key. The key itself is just a sequence of bytes, and we can automatically generate one for the sake of our demo by using fernet.generateKey. With that, we can then encrypt whatever data we pass in with that key, and then decrypt it with the same key. Now, this demo is not very useful because we can't provide a key. It's more useful to have a key that we know of in advance. So to that end, you might be tempted to do something like this, to generate a key and embed it in the source code. But this is a gigantic mistake for two big reasons. One, you never want to embed any kind of secret information in source code. That makes it trivially easy for someone else to discover and use against you. Even if you think that's never going to happen, it's still terrible practice. That leads me to the other reason not to do this. You don't want to depend on any one particular key if you can help it. You don't want to hard code keys. What you want instead is to have some mechanism for allowing the user to provide a key. That way, the key and its safety are entirely up to the user, not you. A common way to do this sort of thing is to have a secret, like a key, read in as an environment variable on a per session basis. So in this version of the program, we do that with os.getEnv. We read in a variable called fernet_key and use that as our key, or we can generate one if none is supplied, but that's just incidental to what's going on here. Now I also have here a PowerShell script that sets the variable in question and runs the program. Now this means I have to be careful with my key here, but at least the program isn't inherently unsafe because a key has been hard-coded into it. There are other ways to store keys safely as environment variables for only as long as they're needed, but the basic idea should be clear. Don't store keys in code, and store them only where and as long as you need them. The burden of supplying a key should always be on whoever is using the program, and they should supply it in a way that's as decoupled as possible from the program and as ephemeral as possible. Another common thing that we can do with encryption is protect passwords. For instance, passwords that are stored in a database. And that's another area where it's really easy to shoot yourself in the foot. You never want to store a password in a database as is. What you want to do instead is take the password, derive a hash from it, store the hash, and use that to check against any password attempts. Now, the fernet encryption that we used before is not for passwords because it's theoretically reversible. You can get the password back by using the key. For maximum safety, we're going to do something else. We're going to use what's called a hash. We transform the password in such a way that it is not possible to get the original. But if someone else follows the same transformation steps, they get the same result. Here's some example code using Python's own built-in hashlib library. So to hash the password, we're using this function, pbkdf2hmac. This is a hash system that is specifically designed for hashing passwords. See, when hashing a password, we want to use a hash algorithm that has a few important behaviors. One of them is that it needs to be slow. Now that may sound counterintuitive. Surely with computing, we want things to be fast. But the idea is that if we impose some not easily known amount of time required to derive the hash, We can prevent someone from trying to guess the password in a reasonable amount of time. That's what this hash iterations number is. That's how many times we run the hash algorithm. 100,000 is a good number to start with. You can use a lot more than that, and in fact, it's recommended. Another thing we have here is a salt. This is some extra data, randomly generated and stored with each user that we would keep passwords for. It's there to add more randomness to the hashing process on a per user basis, so it cannot be duplicated easily unless you also have the salt. Now, when we generate the hash, which is shown here in hex, there is no practical way to get the password back from it. We store that hash somewhere along with the salt. The password itself is never stored anywhere on our end. Now, when we need to verify the password from the user, we take their input and we hash it the same way we did. Same algorithm, same salt, same iterations. And if we get back the same hash out the other end, then we verified it's the same password. And all of that without us ever storing the original anywhere. One more thing is worth pointing out here. A badly implemented encryption is in some ways worse than no encryption at all because it gives you a false sense of security, both you and the user. If you want to add encryption to a project in some form, you look for an existing vetted project that accomplishes the same things, see how they do it, and seek out as much expert advice as you can for how the whole thing should be implemented. And to sum up, don't write your own encryption, don't store secrets in code, and store well-salted, heavily transformed hashes, not passwords. And that's it for this episode. If you liked it, leave a comment below, and don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and Infoworld.com.